protocol is time-based protocol, right? Again, this concurrency control protocols like graph-based protocol or time-based protocol or validation-based protocol, they ensure that there is no deadlock, like multiple transactions can proceed with execution without any conflicts, right? So in the case of time-based protocol, we need to order the transactions on the basis of the arrival time, right? So let us assume that the transactions arrive in the order T1 followed by T2 followed by T3. Then the timestamp of T1 is going to be less than timestamp of T2, and the timestamp of T2 is less than timestamp of T3, right? So let us assume that the first transaction starts at time 1 o'clock. Maybe the second transaction starts at time 1:30, and we use a system counter for associating a time with a transaction. Like the third transaction starts at a time T3, right? So the timestamp of T3 is greater than T2, and timestamp of T2 is greater than T1, right? So the transaction which comes first, they will have the lesser timestamp, right? So this serial schedule is equivalent serial schedule for this timestamp is like a T1 transaction. T1 gets executed followed by transaction T2 followed by T3, right? So the idea is that every transaction is associated with a timestamp based on its arrival time, and that transaction which comes first will have lesser timestamp, right? So in this case, for each and every data item, we can maintain two timestamps, namely a read timestamp and write timestamp. So right, so read timestamp TS, right? So that, so for example, consider this data item capital X. So multiple transactions, they have performed a read operation on the data item. So we need to find the youngest transaction, right, which has the largest timestamp value. It's known as read timestamp, right? So read timestamp of your transaction is the youngest transaction which has performed the read operation, right? So which has arrived first, right? So the youngest transaction which has performed the read operation is known as the read timestamp of a particular data item capital X. Similarly, write timestamp of X is given by the timestamp of the youngest transaction which has performed write operations, right? So simultaneously we have many transactions performing write operation. T1, it performs a W1 operation. Let us assume that T2 performs W2 operation, and so on, right? So the youngest transaction which performs the timestamp of the youngest transaction which performs the write operation is known as the write timestamp, right? So each and every data item has a read timestamp and write timestamp associated with it. Right. So whenever you are going to perform a read operation, on a data item, it may conflict with a write operation. Whereas whenever you are going to perform a write operation on a data item, it may conflict with either read or write operation. So whenever a transaction issues a read operation on a data item X, right, we need to check only one condition, right? So when a transaction T issues a read operation on a data item capital X, read operation conflicts only with write operation, whereas write operation can conflict with both read operation and write operation. So according to this, we are going to have this algorithm, right? So if write timestamp of X is going to be greater than timestamp of transaction T, you are going to abort it and roll back, right? So it means that a later transaction has performed a write operation after the read operation has taken place, right? So once you read something, you have read something, but some other transaction, later transaction is going to perform a write operation, then it's not logical to read some old value, so you are going to abort and roll back. Whereas if read timestamp is going to be read timestamp of a particular data item is going to be less than timestamp of a transaction, you are going to assign the timestamp of the transaction to the read timestamp, right? Similarly, whenever a transaction TI issues a write operation, so write operation can conflict with both read operation as well as write operation. So you are going to check whether the read timestamp of X data item X is going to be greater than timestamp of transaction TI, or write timestamp of data item X is going to be greater than timestamp of TI. We are going to abort the particular transaction and roll back, like similar to the previous case. Else you are going to perform write operation and you are going to update the write timestamp to the new values, right? So this is about working with timestamp based protocol. So the last protocol in concurrency control protocol is validation based protocol. So let me share it. So I have some bad document format also for this same thing, graph based protocol. Whatever I have discussed, it's in a graph based in a bad representation also, right? So that you can refer to it. So the last thing is validation